All right, got another one take wonder coming at you. We're going to talk about rational functions. I'm going to break this into little pieces, but there's so much to do with rational functions, and they become a really important part of Algebra 2 and the end of Algebra 1, depending on your class. So we're going to dive right in and take a look. So share my screen. Yep, right to there. Share it. Okay, so yes, I want to annotate. I always want to annotate. We've got a hyperbola. This should look a little bit familiar if you remember the last video about inverse variation. And the fun thing about these is they have asymptotes, places where the graph does not go. And we're going to talk about asymptotes a little bit more in depth today. So rational functions, aka algebra invades your fractions. The mother function is f of x equals 1 over x. Like I said, type of graph is a hyperbola. Talking about the domain of these functions, whenever we talk about the domain, we mean what x values can we actually plug into this thing? Well, on the mother function, it's the set of x, that line means such that, x does not equal 0, meaning all x values, but not 0. And that makes sense, right? Because we have an asymptote here, this graph will never, ever be like touching this line right here. So in this case, the y-axis. The y-axis is the asymptote. So it can be anything but 0, right? X, the set of x such that x is not equal to 0. Close that set. Range, same thing. All y values except 0. The set of y such that y is not equal to 0. Okay, so there it is. Y cannot equal 0 here. Sorry, y. So we also want to note about rational functions that x can never be 0 since division by 0 is undefined, right? We don't ever have division by 0. So if we have f of x equals, I don't know, 15 over x, we can never plug in a 0 here, right? Because then you'd have 15 divided by 0 and you get sucked into a black hole. I don't know what happens. It just doesn't make any sense. We don't define it. We call values that cause the denominator to be 0. We call values like that excluded values. We exclude them from our function. They are not welcome. They are not allowed. Okay, so anything that makes your denominator 0, there's an asymptote there. We don't want it. Okay, so we have to actually focus on and find these excluded values in order to work with these rational functions, because sometimes there's just holes in your graph. It's better than holes in your pants, I guess. All right, let's clear my annotations and scooch on down. It doesn't like this. Come on down. All right. So, blank space. All right, so here we're going to talk more about excluded values and where to find them. And let me be perfectly clear, I made this slide years before The Fantastic Beasts and Where to Find Them came out, like years beforehand, and nobody got my joke until that movie came out. All right, so get my annotations out, and we are going to state the excluded value for each function. Okay, don't panic, just parse carefully through what you're hearing here. The excluded value, we said, is where the denominator will equal 0. Okay, so if we just have something, and I apologize for the way this looks, it's kind of hot garbage. I did not know how to use equation builder when this was made. Y equals -2 over x. What value of x makes the denominator 0? This is not a trick question. It's 0, right? The excluded value for this function, y equals -2 over x, is 0. Cool. So x cannot equal 0. All right. Now we've got y equals 2 over x plus 1. Oh no, there's more than just, that's, yeah, don't panic. What we need to do is we need to think what value would make this 0. Okay. So to find out what would cause a denominator to be 0, you set it equal to 0. And solve for x. Now in this case, I know all of you were like, I can do that in my head. That's just -1, duh. Okay, yeah, you're right. fair point. You can do that in your head. However, we always start with the easy stuff, use the procedure on the easy stuff where it makes sense, and then we bring that procedure up to the stuff that you can't necessarily do in your head. So let's just go ahead and say, all right, I need to find my excluded value. So I'm going to say x plus 1 equals 0. I'm setting my denominator equal to 0, subtracting 1 from both sides, and shocker, x is equal to -1. Now, the actual fact is x is not actually equal to -1. X can never equal -1. Okay, so x can never equal -1. What's the excluded value? Okay, what value turns this into a 0? I know, you're all going, it's 2, I did that, it's easy. Let's just go through the steps here real quick. We set it equal to 0 to find out what it cannot be. 4x minus 8 equals 0. You add your 8. That's an 8, I swear. And then you have 4x equals 8. Divide by 4. And x equals 2. So 2 is your excluded value, so x doesn't ever equal 2. All right? Not so bad, right? Not so bad. Sounds all fancy. Find the excluded values of the function, but it's really just like solve a quick little equation. You just have to know what you're talking about. All right, so let's scooch down again. White space. All right, now let's talk about asymptotes. All right. Your excluded values turn into asymptotes, okay? Because remember, it's what x can't equal. So if it's what x can't equal, look at this right here. If you're looking at this, I'm gonna make sure that I have my annotate up so we can see it better. All right, spotlight. So, spotlight? No, oh well, doesn't want to. So this right here is being a pain. This here is an x value, right? There it is on the x-axis. Nothing has this value. This will approach this asymptote. It's not spelled how you thought it was, is it? Will approach this asymptote and never, ever, ever touch it. Don't touch your asymptotes. Don't touch your friend's asymptotes. All right, so over here, there's the horizontal asymptote. Now that's going to be an excluded value of y. I know, it's sideways. Your brain's like, x is horizontal. No, 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 no. This is a horizontal asymptote, but it's where the y values do not dare to tread, okay? The vertical one is where the x values aren't gonna be, okay? So I love this cartoon. Gandalf. You shall not pass the asymptote, all right? And this is how we draw them. I found this graphic online. I don't know what teacher did this, but as you're graphing asymptotes, your math teachers will get fussy at you if you draw bad graphs that approach the asymptote and then curve away. No, it's not a parabola. Obviously, you don't cross over your asymptotes. Take just a little bit of care, people. Don't go straight down towards it and stop. No, it's a curve. And then finally, the good one goes close to it and doesn't quite touch it. We don't expect you to be Michelangelo, but you can make a little effort to not draw your asymptotes like this. Okay, so let me see here. Scooching down. All right, this is my little joke. Asymptotes will increase forever. Okay, it says a hole in the graph. I don't like this slide because they're kind of a hole in the graph. I used to have a teacher that would say, you better know your asymptotes from a hole in the graph. There are actually graphs in rational functions that actually do have a hole. Like they'll just be like a line, but there'll be one place there's just an undefined value, and then the line will continue on its merry way. That's a hole in the graph. An asymptote isn't quite a hole in the graph. It's really just where it increases or decreases at that point forever, but never reaches that value. Sort of like the concept of limits as you guys get into calculus. So asymptotes are those places where x and y dare not tread. Not really holes in the graph, but the graph will approach the value forever. Asymptotic high five. The fun never ends. All right. I always bug you guys to be precise in your math language. That was a chance for me to correct myself there. All right, so let's talk about finding the horizontal and vertical asymptotes. Okay, let me get it back. So we can find the horizontal vertical asymptotes in the following ways. This over here, I'm hoping that you guys can see my cursor, and I'm trying to get it back. Hello, come back to me. There we go, annotate. All right, this over here is sort of a very standard form of many rational functions, okay? You know, when you start to see lots of letters in there, y equals mx plus b, it's a thing that you see frequently, and we can sort of look at the patterns in it. So here we have y, or f of x, right, equals a over, notice your x is always in the denominator, x minus b, or plus b, or whatever. And then on the outside, we have a plus c, okay, where a does not equal 0. Obviously, you're not going to have it being 0, because then you just, what would be the point of that? It'd be 0, y equals 0. That's just the x-axis. All right, so vertical asymptote. So if you're looking for your vertical asymptote, remember, that's the asymptote that, if this is your graph, the vertical one is going to be where there's an excluded x value. It's where x makes the denominator 0. So we have been finding, when we did those excluded values, we've been finding the vertical asymptote, okay? The horizontal asymptote, guess what? It's just c. Yay! Something easy. It's just c. And that makes sense if you think about how functions shift. Whenever you have a plus something or a minus something, a function will move up or down. Like if it's y equals x, it would be here. If it's y equals x plus 1, it would be up at plus 1, right? That's the same thing. Even if it's an asymptote, where you have something like this, and there's like an asymptote going through here. It's very crooked, I apologize. It will never be crooked. Well, it will be crooked like this, but it's not right now. This is just badly crooked. Let's pretend it's actually horizontal here. If I were to say it's now plus 1, it would just shift this whole thing up 1, right? There would be your new asymptote. Your new asymptote would like go through there, and then your graph would shift up to it like that. Okay, so the horizontal asymptote is always nice and easy. It's just taken everything and shifted it up or shifted it down if it's minus, obviously. So that's a nice, easy one to find. Okay, so don't ever stress that one. All right, get rid of that nonsense. All right, so Fist Pump Baby is telling you, all you have to do, if I don't look at something that's crazy and be like, oh no, this is much more complicated than I've seen before. How do I find my vertical asymptote? Don't even care about C. Just look at your denominator, set that denominator equal to 0. That's where your asymptote's going to be. All right, so moving on. Well, let's put this in practice. Okay, I've got some of this graphed for you. We've also got our reminder of how we draw hyperbolas. All right, identify the asymptotes of the function and then graph it. Here we go. Now, got some of this written in already. We have y equals 2 over x minus 4. Okay, identify the asymptotes first. So we see that we have a minus 4 right here. And what we said was, whenever you have this situation where you've got y is equal to a over x minus b plus c, this here is your, think about it for a second, it's your horizontal, right? That's your horizontal asymptote, is right at the end. This is the one that goes sideways, side to side, if you have a person that has trouble remembering what horizontal means, like the horizon. And ta-da, we can draw it in. I've already drawn it in for you, okay? So horizontal asymptote at minus 4, that purple dotted line there, that's an asymptote. Now we set the denominator equal to 0, which is just x, so yeah, x equals 0 is our vertical asymptote. So you'll see over the axis, which is in red, I've made a dotted purple line to kind of show you, oh, look at that. There is the asymptote, okay. So, once you have your horizontal and vertical asymptotes, it's now a question of choosing some points, okay? Make yourself a table. This is not always going to be as easy as inverse variation. It's not going to be that much harder either. Okay, we have x values. Let's try 1. What happens at 1? Okay, if I plug in 1, I have 2 over 1 minus 4. 2 over 1 minus 4. Cool, that's 2 minus 4, that equals -2. So there you have it, -2. Okay, if I plug in 2, I have 2 over 2 minus 4, which is 1 minus 4, which is -3. Cool, we've got some pretty good points going here. All right, so I've got the points graphed here. This is me going at 2, 4, 6 just to make room for myself. So you'll notice I made this is actually 1. All right, at 1, I'm at -2. I know it looks like 1, but remember I'm going by 2s. So this is 1, 2. Okay, then I graphed that one. I have my point at 2, -3. So here I am at 2. That's -2, that's -3. And 3, when I plug that in, I got 3.5. That's my best estimate of where that is on this graph. That is not as perfect. And then I chose some negative ones because I know that I have a vertical asymptote right here at 0. That means I can go to 1 and I can also go to -1. So here's my value at -1. All right, -1, -6. And now I'm paying attention. I cannot cross this line and I cannot cross this line. So I know that as I have picked a couple values, I can graph this here next to my asymptotes, trying to do the best job I can. All right, and I see I try to do it over here as well. And so they're not always going to be nestled in your x and y axis. They are for the mother function, but so like so much else, when you shift it down 4, down it goes, right? Shifts down 4. So there's your hyperbolas, right? Pick some points. Once you have your vertical asymptote, you can choose 2 points on either side. That's what I do. I choose about 2 points, and then I kind of draw the lines. It's like 2 points here, 2 points there, and draw the lines. I did a little more than 2, but honestly, when I'm doing them just for demo, I do my best to just choose a couple and estimate the curve. Okay. Your important part of graphing these are getting your asymptotes in the correct place. All right. So scooching on down. All right, let's try one here, all by ourselves, no reminders. All righty, as soon as it decides it wants to, there we go, annotate. All right, and I'm going to use, let's just use black. All right, identify the asymptotes of the function and graph it. So we have, let's see, if I'm thinking of this as y is equal to a over x minus b plus c, I'm looking at this and I'm like, wait a minute, there's no plus c here. There's no plus c, so that means it's plus 0. So that means that my horizontal asymptote, vertical asymptote, which one are we talking about? It's the horizontal asymptote. I'm letting you think about that. The horizontal asymptote is at y equals 0. So once again, we have our horizontal, there I go again, horizontal asymptote, in this case, is right on our x-axis. Cool. I'm doing dots to show that that is my horizontal asymptote. Cool. Now my vertical asymptote is wherever this becomes 0. So x plus 1 equals 0. So then, of course, x is equal to -1. Okay, so I have a vertical asymptote at -1. There it is. There's my vertical asymptote. So I know that my values I'm going to choose are going to be on either side of this vertical asymptote. So what happens if I choose, let's see, here's -1, let's do -2. Okay, if x is -2, what will y be? -2, we plug this into this function. We plug in -2 right here. So we have 1 over -2 plus 1 is equal to 1 over negative 1, which is equal to negative 1. Okay, so I have a point at negative 2, negative 1. So negative 2, negative 1, nifty. What about if I plug in negative 3? Okay, 1 over negative 3 plus 1 is equal to 1 over negative 2. So it's negative 1/2. So I have a point at negative 3, negative 1/2. I can see that this gets pretty close to the asymptote pretty quickly, right? So at negative 3, 1, 2, 3, it's already at negative 1/2. We're already starting to make the curve. And we can also assume, because we know about these types of graphs, that it's also going to be at 1/2 negative 3. Where are you? 1, 2. Where am I? I did that wrong. Hold on. If we plugged in 1/2, yeah, no. All right, so that would not be right. Take back what I said there. I know it's going to be right there because I know what the curve looks like. So if I am curious, I can plug in negative. Oh, that's why, because I'm thinking this is the x-axis. I was thinking this, or the y-axis. I was thinking this was the y-axis, and I was like, what? And I was counting wrong. Okay. So you know that the curve is going to kind of go down to here. All right, and that's at negative 1.5. So 1 divided by 1/2 would be 2. 1, so negative 2. So negative 1.5. Negative 2. All right, so now I've got kind of a curve going here. And by the way, you don't ever have to like calculate that out if you don't want to. Once you get these 2 points here and you kind of can mirror it across in a weird way. This is kind of like the point of symmetry. I just sort of did it, and since I'm doing it on a video, I want to make sure I did it right. And you do your best to show that it's going really close, but never touching. All right. One side. Now this is going to be mirrored across, not across the axis, but across this. All right. This is going to be mirrored here. 0 is not an excluded value. If I plug in 0, I have, let me do my calculation over here. If I plug in 0, I have 1 over 0 plus 1, which is equal to 1. Okay, so I have a point at 0, 1. So there it is, 0, 1. All right, and now maybe I want to know at negative 1/2 what we're looking, or at, yeah, maybe positive 1. Let's just plug in positive 1. Plug in positive 1. At positive 1, we'd have 1 over 1 plus 1, which equals 1/2. So we have a point at 1, 1/2. So at 1, 1/2. And then you can assume that that goes over there. See how it kind of mirrors it. Hopefully we can see that. That's the middle point. And then we can draw the other part. Oh, this is harder than it looks when you are doing it on a drawing pad. Okay, and we have graphed that. We have found our vertical asymptote by setting our denominator equal to 0. We found our horizontal asymptote by noticing that it doesn't have a plus c, so it's 0. It would be at the c if it weren't. We put those asymptotes in, and then we chose some values on either side of the asymptote to graph. 2 is really all it takes on each side. It doesn't take a lot, and we just did the math. We calculated, we plugged in for x to get those actual values. Okay. Cleared our drawings. I think that is the end for today. That is all I'm going to torture you with. If you had been in my class, you would have been doing those pages we just saw. So I'm going to continue with this sort of topic in the next video. More on rational functions to come. And it's hilarious because I don't know how to end my videos. Stop share, that's how we do it. Stop share and stop recording. Bye guys.